Hi, let's solve next previous question of recursive enumerable language. This question was asked in GATE CS 2016 set 2 question number 44. Let's read the question. Consider the following languages. L1, M takes at least 2016 step on some input. L2, M take at least 2016 step on all input. And L3, M accept epsilon. Where for each Turing machine M denote a specific encoding of M, which one of the following is true? For option is given, option A, L1 is recursive and L2, L3 are not recursive. Option B, L2 is recursive and L1, L3 are not recursive. Option C, L1, L2 are recursive and L3 is not recursive. Option D, L1, L2, L3 are recursive. Let's analyze one by one language. First language, M take at least 2016 step on some input. What is the difference between these two statements? Here it is written on some input. Here it is written on all input. Rest are same. So difference is some and all. The first statement, it is recursive as counting any number of steps can always be decided. You are just counting the number of steps and that can be decided. If it will be loop, then it will be not decidable, but it is finite number of steps and counting finite number of steps is always decidable. That's why L1 will be recursive. We can design a Turing machine whether it take more than 2016 steps on some input string W and W length can be less than equal to 2016. So it may halt an accepting state or rejecting state. Decidable means what? It may accept or reject. If it is going to loop, then that is undecidable. But on 2016 step, it may accept or reject. That's why it is decidable, and decidable means it is recursive. Next, L2. L2 is also recursive, as here also we are counting number of step. Counting number of step always can be decidable. Here you can design a Turing machine that will take more than 2016 steps on each input string W, and W length can be less than equal to 2016. It may halt an accepting state or rejecting state. That's why it is decidable. It will not go to loop. Next, if Lm contain epsilon, emptiness is a non-trivial property and it is undecidable as per Rice theorem. In case of Turing machine, finiteness, emptiness, all these are non-trivial property and this is undecidable. Which properties are undecidable means it is recursive enumerable language. It is not recursive. So L3 is not recursive as emptiness in Turing machine is undecidable. We found L1 is recursive, L2 is recursive and L3 is not recursive. So what will be answer? Answer will be option C. L1, L2 are recursive and L3 is not recursive. Answer will be option C. Let me explain through an example. We cannot design a Turing machine for 2016 step. Let me take a small example. Here this is a Turing machine for A power n, B power n, C power n greater than equal to 1. And which string it will accept? It will accept A, B, C, n greater than equal to 1. That's a minimum. It will accept A, B, C. Then 2A followed by 2B followed by 2C, 3A followed by 3B followed by 3C. Now suppose language will be M take at least 6 steps on some input. Then second language can be M take at least 6 steps on all inputs. Then third statement, M accept epsilon. So this is a non-trivial property, that's why it is undecidable. Let me analyze language 1 and language 2 on this Turing machine. So I'm just considering a string A, B, C. Now redirect header is here. If we'll see A, it will be changed to X and will move right. So this A will change to X and redirect header will move right. This is our step 1. Next, when it will see B, B will change to Y and redirect header will move right. So this B will change to Y and redirect header will move right. This is our step 2. Next, when it will see C, C will change to Z and redirect header will move left. So redirect header will be here. This is our step 3. Now when it will see y, y will be y and will move left. Now redirect header will be here. So this is our step 4. Then when it will see x, x will be x and will move right. Now redirect header will be here. This is our step 5. Next when it will see y, y will be y and will move right. This is our step 6, will move right. Then when it will see z, z will be z and will move right. This is our step 7. Then when it will see blank, blank will be blank and will move right. Now the right header will be here. This is our step 8. So this string A, B, C that we did in 8 steps. So here what is the language? M take at least 6 steps on some input. So for string A, B, C, for input A, B, C, it is at least 6 steps. More than 6, it can be any number. We did in 8 steps. So 8 steps is at least 6 steps. It can be 6, 7, it can be 8, minimum 6, more than 6, it can be anything. Next language, M takes at least 6 steps on all input. Here what is the language? A power n, B power n, C power n. And what is minimum string? Minimum string is A, B, C. For minimum A, B, C, we did in 8 steps. Then whatever string we'll consider, whether 2A followed by 2B followed by 2C, it will be more than 8 steps. It will be not less than 8 steps. So you can say for all input, this Turing machine will run at least 6 steps. Here 6 just I consider as an example. You can consider anything. Minimum you can consider 8 also. Okay, no problem. Even you can consider 3, 4, 5. Just for example, I consider 6. So answer is L1, L2 is recursive, L3 is not recursive. Thank you.